In this video, we'll be seeing about test sets, validations for overfitting. Okay, so what does this mean? So in applied machine learning, okay, it is highly iterative process. So when I'm talking about testing, validation, so normally this training, okay, or development or test sets, they are nothing but the highly interactive process. So when training is when while training a neural network, so we'll have to first check that how many neural network layers are there. So how many layers of neural network are there? Okay. Second thing is how many hidden units a neural network should have. Third point is what is the learning rate? What is the learning rate? And fourth point is what are the activation functions? What are the activation function you want to use for different layers? Okay, so when I'm talking about the training or development test set, so we actually normally discuss about this unrepeating overfit, but we'll come to this later. So first we would like to know, okay, what are those training sets and what is that training is all about? Normally, it is nothing but idea where you are building okay, a neural network of certain layers. Of certain layers you are actually building. Then I code them up by using some programming concepts. Then after that, I experiment, do the experiment. Okay, that is how the configuration works. Based on that, the experiment. Then now based on the outcome what I generate out of the experiment, okay, you try to refine the ideas. Okay, now deep learning, okay, is found its successes in various things, that is in NLP, computer vision, speech recognition, lot of applications on structured data sets. So structured data sets can be ads, web search, or logistics, etc. So these normally will have a set of training data. Okay, so training data. Okay. So in that, you can see that there are training sets. Okay. And then there is a holdout data, which is nothing but cross validation, development set, or you can say the dev set. And then there is a test data. So in the process of machine learning, the split normally will have around 70% to 30%. So here 70 is for training and 30 is for testing. But in the previous era, okay, there is to be like 60%, 20%, or 20%. You can say that roughly they used to say that training 60%, development 20, and test 20%. But this was all this discussion is all used to be done when prior to the big data. But when there is a big data being introduced, that is big data is around 1 lakh or 1 millions of data. Okay, so that time we cannot say about like 30% of the 1 million. So for 30% of 1 million, but the you can say the 300,000. Okay, or 50. So these many datas are actually usually waste for testing the data or for development of the data. So effort has to be made where most of the data should go to the training the data rather than testing and development. Even if you can contribute 1% of it for training, so which is nothing but 10,000 of, so that also is a huge number. So you can say that out of the 1 million, you can keep 98% for training, 1% for development, and 1% for testing. So that will contribute like around 10,000 and 10,000. Okay, and you can say 980,000. Okay. So this way you can say that you can have the split up. Okay. So even in case of millions, if you want more data to be in training, you can also keep it as 99.5. And secondly, you can keep it as for 0.25% for development and 0.25 for okay testing. So this is nothing but train, dev, and test. Okay. So you can say the rule of the thumb in this training. So make sure that dev and test come from distribution. Okay, dev and the test come from the distribution, and train set uh, should be the highest number. Okay, so what are the examples of the training set? So you can say that you actually the cat pictures from web pages. So or you actually train that from the data which is coming from the web pages, and dev is nothing but cat pictures from okay users using your app. Hmm. Okay, so here you can see that okay you are training the data from web pages, but the for while development and testing you are using it by app. So not having a test set might be okay, but here you can see that if you're taking it from different uh, platform, still it will not be giving you the appropriate results. So whenever you're training a data set and from one particular sources, so effort has to be made that the development and testing set should be made from the similar data sources, not from different data sources. Okay. So what is the difference between training? So training is nothing but where we are training the data set, okay, from these data sources, whereas the development is nothing but a data set is nothing but to evaluate on particular algorithm. That is, which algorithm is suitable, okay, for those with among those different data sets, which algorithm is suitable for okay for those big huge amount of data. And testing is nothing but okay once we have trained the data, we will be testing with the samples of data and checking the accuracy level. Okay, now here you can see that the bias and variance. So the one with the left and right side is nothing but the underfitting is which is nothing but the high bias. Okay, and overfitting is nothing but the high variance. Okay, and this one is just right. Okay, now why would you say that? Because here you can see that for a particular problem statement, if you are putting a straight line, you can see a linear algorithm. At that point of time, we could see that an algorithm is having a, a high accuracy level, but still there are some errors. You can see that some of them are coming, okay, to the another part category, another portion of the line, another side of the line. So this and let's see, um, because of that, uh, there is a slight error which you can see. Okay, and this is known as the high bias. High bias is nothing but the high error rate. Okay, when there is a high error, that means that it is an underfitting. So you can compare yourself for, okay, you are trying to, okay, get into the wearing a t-shirt or wear the pant or shirt, okay, which is very tight, okay, which is very tight. So so you have to loosen it up. So for loosening it up, I actually use a quadratic. You see that same way, data is loosened up by using a quadratic, okay, algorithm. Now this quadratic algorithm, you can see that although there is a, it is considering all the aspects, and you can see a few errors are there, but still it is trying to fit in the data, all the data. So in this case, there it was not fitting in all the data, but here you are fitting in all the data. But still there are some errors. Now what do you do is you try to, okay, what, fit the all the data very accurate. Now very accurately means it is something which is overfitting. So when it is overfitting data, then it is known as the high variance. Now the example can be, consider a cat classification, okay, where you can say y is equal to 1 for cat and y is equal to 0 for dog. When a training set, when do you say a training set error is when it is a, when a training set is 1% and dev set is, okay, around 11%, then it is at a high variance, high variance, okay, and low bias. When your training set is 15% and dev set is 16%, then you say it is high variance, sorry, high bias, okay, but low variance. When you training set is 15% and dev set is 30%, it is high variance and high bias. Same way, if it is training set is 0.5% and dev set is 1%, then it is low bias and low variance. Okay. So these are the different types. Okay. So if anyone has any queries, so we can solve it in the class. Thank you.